All right, so today we're going to be talking about molarity, which is a way that we measure concentration in solution. And it's not the only way that we measure concentration, but it is the main way that we measure concentration. And so we're going to be focusing mostly on this in my class. Now, before we really get into molarity here, we do need to make sure that we remember milliliters and liters. These kind of things can be pretty hard for students, and so I like to go over them here. Just remember that 1 liter is equal to 1,000 milliliters, or 1 milliliter is equal to 1/1000th of a liter. And really all you have to do is move your decimal point back and forth 3 places. So for instance, we have 250 milliliters here. All we have to do is we know that liters are going to be bigger, so we're going to be moving the decimal to the left 1, 2, 3 places. And your answer here is going to be 0.25. So 250 milliliters is 1/4 of a liter. Now down here we've got half of a liter and we want to get it into milliliters. This one we're just going to go the opposite direction. We have 0.50. We're going to go 1, 2, 3 spaces to the right and find that half a liter is 500 milliliters. Now I know I'm going through this pretty quickly, but as you practice this, it gets a lot easier, and so I don't want to spend a ton of time on it. Here we're going to go again 1, 2, 3, and 1.25 liters is 1,251 milliliters. Now molarity, but the way we calculate it is we take moles of solute, which is the thing that we dissolve, and it's over liters of total solution. And it's important to remember that you're not saying liters of solvent. Because solute does take up an amount of space, we have to do total liters of solution. And so down here, if you wanted to make a 1 molar solution of NaOH, you would find 1 mole of NaOH, which happens to be 40 grams. You would put that in the bottom of this flask over here, and then you would fill the water up to 1 liter. You wouldn't add 1 liter total of water. You would measure to 1 liter, including the volume of the solute. This right here is called a volumetric flask. We would use these to create really precise measurements of volume. They have only one mark right here. This line is measuring 1 liter, and that's the only mark on this flask. So they're a lot more accurate than beakers or graduated cylinders even. Now the last thing I want you to notice here is that this right here, this is the unit we use, M, capital M. If we used a lowercase m, it would be indicating meters and not mole. And so we need to make sure that we're using a capital M here. I will often write the formula very simply just as this right here, M equals mole per liter, just because it's a little easier for me to deal with it that way. And the point I'm trying to make here is that we don't always leave it in a fraction. We usually calculate it out. So here, if we have 1 mole of substance and 1 liter of solution, we are going to end up with a molarity of 1 because 1 divided by 1 is 1. Down here, 2 moles per 1 liter is going to give us a molarity of 2. And then this one right here is going to give us a molarity of 2 as well. Now, if we had something like 1 mole for every 2 liters, we would end up dividing that out, and we would get that a molarity of 0.5. And our units there are capital M. Now, I say that I do this all the time because I really do. This is something that is done quite a bit because chemical is not typically shipped in solution form, except for in very few cases. It's a little bit more convenient because then the chemist can decide what molarities to make in their own laboratory or in their own classroom. Additionally, you're not going to be dealing with the space issues that solutions can give. So here's just an example that we're going to go through really quick. Now, before we get going on this, I want to tell you that there are 3 steps to this type of problem where you're trying to find the molarity given the grams of substance. The first step, you're going to find the molar mass. The second step is to go from go from grams to moles. And then the third step is to use our formula. Okay? So in this one right here, 45 grams of hydrogen fluoride is dissolved in enough water to make 500 milliliters of solution, and they want us to find the molarity. So the first step here is to take the formula that we've been given, hydrogen fluoride, and to go ahead and calculate out the molar mass. Now this problem is not in your packet. I'm putting it here just so that you can see me go through one problem without having to follow along and write everything down as I go. So if we look on our periodic table, if you can't remember, what you have to do is look at the periodic table, figure out how many grams per mole the substance is, and you do that by looking at the atomic mass. So hydrogen has an atomic mass of 1.01, and fluorine has an atomic mass of 19.00. Your numbers might be slightly different than that just because of rounding differences in your tables or on your tables, but this is going to get you close enough to the answer that you should just be fine. So that's going to give us a total mass of 20.01. So that's our first step done right there. The next step here is to go from grams to moles. Now we've been given 45 grams of hydrogen fluoride, and we have our molar mass over here. So now we can go ahead and convert. And the way we do that is we draw our little crosshatch hairs thing. We put 1 mole on the top because that's what we want to get into, and grams is going to go on the bottom so that it will cancel out. Now the number that we put down here is going to be the number that we found earlier, if you remember correctly. So this is going to go right here, 20.01, and then you're going to just go 45 times 1 divided by 20. Grams will go away, and we are going to be left with 2.247 moles, roughly. You might have, again, a slightly different answer, just depending on rounding and what your periodic table says. All right, so that's step 2 done. So now we need to do step 3, which is to plug it into the formula. And if you don't remember the formula, I'm going to write it down here. Molarity equals moles of substance per liters of solution. And they've given us liters of solution over here in the problem. So all we have to do is draw our dividing line and put that down here. Now, you might have noticed something already. We have to have our our volume of solution has to be in liters, not in milliliters. So if you remember correctly, we're just going to go 1, 2, 3. 500 milliliters is 0.5 liters. And so then we just take 2.247 moles divided by half of a liter, 0.5 liters, and we will get a total molarity of 4.49 molar, or roughly 4.5 molar. That's how you do this. So I'm going to go through the next problem a little bit slower now. All right, so now we're going to be doing this practice problem here, and I'm going to try and go pretty slow here. I do have some time constraints because of how long YouTube videos are allowed to be on mobile devices, but we're going to try and get through this. So like we said, step number 1 is to go ahead and find our molar mass. We have sodium, oxygen, and hydrogen. And if you look on our periodic table, I'm going to go through this pretty quickly here, but we can find each of these values just on the periodic table. 22.99 there, 15.99 here, and 1.01. And if we add all of those up, we get 39.99. That is step number 1, to find the molar mass. Step number 2, like we said last time, is to go from grams here to moles. Now this problem here has us doing 10 grams of NaOH. We're going to just write 10.0 grams, draw our little crosshairs, and we're going to put moles on top and grams on the bottom. And if you remember, here's the number that should go in that blank. We've already found it. So 39.99. We're going to go ahead and do the math. 10 grams times 1 divided by 39.99. And we are going to get 0.2500. I only like to carry to 4 decimal places. You can carry to more if you'd like. Now this is moles of NaOH. So that's step number 2, is to go from grams to moles. The third step is to use our molarity formula, which again I'm going to write down here in the corner. Molarity is equal to moles per liter. So we're going to go ahead and divide. We've got our moles up top. Now we've got to find the volume, and it's up here in the formula, but again, we're in milliliters. Now, if you're having a hard time remembering milliliters versus liters, just imagine a 1 liter beaker, and it's going to have these little tiny milliliter marks on the side. So you can remember that 750 milliliters is going to be a lot smaller than 1 liter. Not a lot smaller, but smaller. So we're going to go ahead and move 1, 2, 3 places over, and we'll find that it's 0.75 liters. Okay, 0.25 divided by 0.75, you plug that into your calculator, and our final answer down here is going to be 0.3334 molar for our units. That's it. That's how you do this. So for the next 2 problems, give them a shot on your own, try them out by yourself, and then have me check them in the video coming up. So hopefully you've already given it a shot here, but let's go ahead and go through this. I'm not going to take too much time here. K and F, first we find our molar mass. Potassium is 39.10. Fluorine is 19.00. We add those up and we get 58.1. That's step number 1. Step number 2, down here, 0.54 grams of KF dissolved with enough water to make this many liters. Now you'll notice this is different than it is in your packet. Please correct it in your packet if you haven't already. All right, so we're going to come down here. We're going to go from grams to moles. That's the next step, grams. We go from this many grams, blank grams on the bottom, 1 mole on top. We already found the number for the blank, 58.1. Grams goes away. We're going to go ahead and divide that out, and we are going to get 0 point, a lot of zeros, 1, 2, 3, 9, 2 moles. All right, that was step 2. Last step is to plug it into our molarity formula. Molarity equals moles per liter. So go ahead and do that. You're going to divide by your liters, and this time we don't have to convert because it's already in liters. So 0.272. And we are going to get for our answer, we just plug that into the calculator, 0.0034 molar. Okay, if you did that one correct, awesome. If not, go back, try and rewatch them through slowly, slow this version down if you need to, and give the third one a shot by yourself. Let's do this third one now. Okay, if 188 grams of NiBr2 is dissolved with enough water to make 500 ml of solution, what is the molarity? First, Ni has a molar mass of 58.69. Bromine has a molar mass of 79.9, and hopefully you caught that there are 2 bromines in this formula here. So you need to multiply that by 2 to get the correct answer, and our total molar mass is going to be 218.49. All right, step 1 done. Step 2 is to go ahead and go from grams, 188 of them, into moles. Blank grams on the bottom so that it will go away. 1 mole on top. 218.49 right there. So 188 times 1 divided by 218.49 is going to give us 0.8604 moles, because that's the unit we'll be left with right here, divided by 500 mils. Now, if you remember, 500 mils is half of a liter. We found that by going 1, 2, 3. So 0.5 liters. We go ahead and divide those out in our calculator, and we are going to get a molarity of 1.7209 molar. That's how you do it. The next few problems in the homework will be done in a second video because they are working backwards, and I want to be able to devote enough time to those. So do your practice problems in your homework. Come ready to class to be able to do the molarity quiz.